All right, welcome everybody. Welcome to another video. Today we are talking about acceleration. So let's just jump right into it. Okay, so I want you guys to look at these two graphs here, and I want you to see the difference between the two. All right, on the top we have a jogger, and on the bottom we have a sprinter. Notice the timeline. Okay, the timelines are right here. So 0 seconds, 1 second, 2 seconds. Same for the sprinter, 0 seconds, 1 second, 2 seconds. And down at the bottom, we have the distance that they're running. Okay? Now, if you look at this, what you'll notice, okay, outside of the fact that the sprinter had a head start, which is cheating as far as I'm concerned, but look at the distance that they cover. Between each second, this jogger goes the exact same distance. Whereas the sprinter starts off going a much smaller distance in between 0 and 1 second, but that distance gets greater every second that passes, all right? The jogger is jogging at what we call a constant velocity, meaning every second his distance is exactly the same. He's moving at the same speed. Whereas the sprinter, right, he starts from nothing and immediately every second, his speed is changing, all right? So I want you to keep that in mind. It's fair to ask in your day-to-day life if your velocity is constant or if it's changing. And if you really think about it, the truth is that throughout your day, unless you're sleeping, sitting in your desk, or if you have cruise control on your car, your velocity throughout your day is always changing. We have a name for that, okay? We call this acceleration. Acceleration simply is a change in your velocity, all right? Now, the units that we use for acceleration look kind of familiar. We're going to talk about this, but they are meters per second squared, okay? And this is going to be something that's going to be really important to get under your fingers, to get in your brain as quickly as possible. Whenever you see meters per second squared, we're talking about acceleration. Now, it's important to note, acceleration is a change in velocity, right? So obviously, it's going to be a change in speed, right? Anytime your speed changes, when you go from fast to slow or slow to fast, that's acceleration. But remember, velocity is speed with direction. So anytime you change direction, you are also accelerating. That's really important to remember, okay? It's a change in your speed, so speeding up or slowing down, that's acceleration, or a change in direction. Anytime you're turning, that is also an acceleration because your direction is changing, okay? All right, so again, I want to point out the difference between velocity and acceleration. I think that this is important. Remember, velocity is speed with direction, okay? Acceleration is a change in your velocity. So this is how fast you're going and what direction you're moving in. Acceleration is a change to this, and it can be either in speed or direction, all right? The big thing to notice here, and something you should always check whenever you're doing these problems, are your units. You're going to hear me say this a lot throughout the year. If you check the units, you'll know what you're talking about, okay? Whenever you see meters per second, that's always going to be a velocity. And whenever you see meters per second squared, that's always going to be an acceleration, okay? Okay. All right, so we're just going to jump into it. Today is a big equation day, all right? Now, do not let this overwhelm you, all right? You are going to have a copy of this sheet that has these equations as well as all the other equations that you need, okay, throughout the rest of the year whenever you take any kind of DOL, quiz, test, even your ACP, you'll have an equation sheet, okay? So you don't have to memorize this. All you have to do is know how to use it, okay? So last class, we talked about our velocity equation, okay? It's called average velocity. I just write a V because it's faster. Velocity is equal to your change in displacement over change in time, okay? V equals d divided by t. That's what we did last class. We only use this equation if the velocity is constant, okay? If your velocity is changing, meaning that the velocity you started with is different than the velocity you end with, you're going to want to use one of these three equations, okay? So I want you to make sure you take the time to write these down, okay? You can take a second, pause the video, pause, come back, all right? Let's go through these. So the first one says acceleration, A, equals VF. VF is your final velocity, okay? Remember, I always told you it's always final minus initial. You can see that right here. So it's your final velocity minus your initial velocity, which means this is the velocity you start with, this is the velocity you end with, divided by your change in time. That's how much your velocity is changing. That's acceleration. Now we have two other equations. This one, we use less, but we still use it. Acceleration equals the final velocity squared, important, minus the initial velocity squared, divided by 2 times the displacement, all right? And don't worry, I'm going to go through how to use all these in just a second. And then lastly, the big one, which we're actually going to use quite a bit, your displacement equals your initial velocity times your change in time, plus 1/2 times your acceleration times time squared. Okay, so again, we're going to go through, I'm going to do a bunch of practice problems right now, all right, so you can see how all of these work. Remember, you don't have to memorize the equations. You're going to be given the equations. You just need to know how to use them. Okay, let's jump into it. Number 1. All right, a missile hits a spaceship. It goes from being stationary to moving at 300 meters per second in only 0.5 seconds. What is its acceleration? So remember from last class, we always use the guess method. And here, I will show you why it's important. So step number 1, write down our givens. Okay, a missile hits a spaceship. It goes from being stationary to moving at 300 meters per second. Meters per second is always a velocity. Now we have an initial velocity and a final velocity. Well, I know that my final velocity is 300. Why? Well, because that's the velocity that we end at. That's the ending velocity. I don't see an initial velocity here, but I see this magic word, stationary. You should know that stationary means not moving, okay? You're at rest, which means our initial velocity is 0, okay? And we see 0.5 seconds, and we know seconds always measures time. These are my givens. Next step, what's my unknown? What is the acceleration? Well, it tells me what my unknown is. All right? Step 1, always make a chart. Always, always. Okay? Step number 2, now we have our givens, our unknowns. All right, step number 3, we have to pick our equation. And I gave them to you right here so you can see them. What you have to do is you have to see the units you have and find the equation that has all of them. So we have, let's look at our first one. Do we have acceleration? Check, that's what we're looking for. Final velocity, check. Initial velocity, check. And time, check. We're going to use this equation right here. So we're going to have A equals VF minus VI divided by time. I write the equation down. Fourth step, substitute. I just put my numbers in. Acceleration equals 300 minus 0 divided by, right? That's my VF, 300, VI, 0. T is 0.5. I bring this down. Acceleration equals 300, because 300 minus 0, in fact, I'm just going to do this right here. 300 minus 0 is 300 divided by 0.5. Get your calculator out. 300 divided by 0.5 gives me an acceleration of 600, and my units, meters per second squared. Boom. Okay? Textbook acceleration equation. All right? Take a second. Good? Good. All right. Next up, we talk about spaceships. Now we're going to talk about boats. Okay, so let's look here. A resting boat begins moving and ends up going 20 meters per second. Okay, if the boat travels 50 meters, what is its acceleration? Step one, write down what you know. Collect what you got. Okay, so it says a resting boat begins moving. If the boat is resting, do you know what its initial velocity is? Ah, very good. You are learning. Its initial velocity is 0. Okay? And begins moving and ends up going 20 meters per second. Meters per second is always a velocity. In this case, it is our final velocity. Okay? Boom. If the boat travels 50 meters, all right, remember from last class, meters always measures, you got it, distance. And last but not least, this is everything we're given. Now we need to figure out what we're looking for. Well, that's easy. It says, what is its acceleration? All right, I have my givens. I have what I'm looking for. Now we got to pick an equation. So let's look at our first equation. Acceleration, check. Final velocity, check. Initial velocity, check. Time, well, we don't know the time, all right? So we can't use that first equation. So let's look at the second one. Acceleration, check. Final velocity, check. Initial velocity, check. And distance, check. Excellent. So we're going to use the second equation. So we have acceleration equals final velocity squared, very important, minus initial velocity squared, very important, divided by 2 times the distance. I plug in my numbers. This gives me acceleration equals my final velocity, 20 squared, very important, minus my initial velocity, 0 squared, divided by 2 times 50. All right. Okay. So I'm going to go ahead and do this math. All right. So I bring this over here. A equals 20 squared is 20 times 20. Your calculator will tell you that's 400. Minus 0 times 0 is 0. Divided by 2 times 50. 2 times 50 is 100. You got two $50 bills, you got 100 bucks. Bring it over. 400 minus 0 is 400. Divided by 100. And 400 divided by 100 gives me 4. It's an acceleration, so it's meters per second squared. That's it. Just that easy. Make sure you make a chart. Make sure you write down the equation. Plug your numbers in. And most importantly, don't just put this into your calculator. I can't stress that enough. You want to do every little step here so you can see what's moving. And the more things you put in the calculator, the bigger your chance you have to miss a parentheses or just trust me on this one, okay? All right. Moving forward. Next up, we got a runner. There is a woman running at 3 meters per second. If she accelerates at a rate of 2 meters per second, how fast is she going after 10 seconds? Step 1, write down what you know. There is a woman running at 3 meters per second. So we know that when she starts, when we enter this movie, this woman is running. So we know that her initial velocity, her starting velocity, that's what the I stands for, is initial, is 3 meters per second. She accelerates at a rate of 2 meters per second squared. So I know my acceleration is 2 meters per second squared. Again, velocity, meters per second, acceleration, meters per second squared. Even if it didn't say acceleration, I would know that's the acceleration because of that meters per second squared. How fast is she going after 10 seconds? Well, we know 10 seconds is equal to our time. Now this time, it doesn't explicitly say what we're looking for. It just says, how fast is she going? Well, how fast you're going is your speed. And not just speed, but your velocity. And if it's after 10 seconds, that means it's at the end. So we're actually looking for our final velocity. All right. Okay? Givens, unknown. Let's go over to the equations. All right. Can we use number 1? Acceleration. We know that. final velocity. That's what we're looking for. Initial velocity, boom, time, we got it. Okay? This is our favorite equation. If we can use this one, we will. Write it down. Acceleration equals final velocity minus initial velocity divided by time. Right? That's step number 3. Step number 4, plug your numbers in. Acceleration is 2. Put it here. Our final velocity is, I don't know, minus our initial velocity, which is 3, divided by our time, which is 10. Okay, now we have some work to do. We're going to have a couple steps here. Step number 1, let's circle what we want to get by itself. Okay, we want to isolate VF. We want VF by itself. How do we do this? Okay, I know that I told you to go through PEMDAS backwards, okay, but what you got to do here is you got to remember that if you have an equation on the top or the bottom of a fraction, it's really in parentheses. So we don't mess with that yet, okay? We can't just add 3 to both sides. If you have the bottom of a fraction like this, you got to get rid of this first. So the first thing we're going to do is we see division, so we're going to do the opposite of division. So the opposite is to multiply. We got to move this 10. That's the first thing. So we're going to multiply both sides by 10. Okay? Here's what this does. 10 divided by 10 is 1. Okay? It cancels out. Now I bring everything down, and now I have 10 times 2 on this side. That's 20. And that equals my VF minus 3. Everybody see that? Now this looks really easy, right? Now I have my VF minus 3. Again, I want VF by itself. So I am going to do the opposite of addition, the opposite of subtraction, which is addition. I'm going to add 3, and whatever I do to this side, just like here, I have to do to this side. Negative 3 plus 3 is 0, and this gives me a VF equal to 20 plus 3, 23, and this is a velocity, so it's always in meters per second. This is a really good one, okay? So again, if you're ever trying to get something in the top of the fraction, all right, you gotta move that bottom of the fraction first, okay? And by doing that, this is division, so you always multiply by whatever's in the bottom of the fraction. I multiplied this side by 10, so I multiplied this side by 10. Take a peek. Good, good. All right. Okay, got 2 more. And I know we have a lot of practice problems, but you know, there's a lot to look at. Let's look at this airplane. An airplane at rest took off and accelerated at 2.5 meters per second. How long would it take the plane to reach a speed of 50 meters per second? Step 1, always write down what you know. Never jump in, just write down what you know. An airplane at rest. We know at rest means 0 meters per second. So that is our initial velocity. Right? We start at rest. It takes off and accelerates at 2.5 meters per second squared. Acceleration equals 2.5 meters per second squared. How long would it take for the plane to reach a speed of 50 meters per second? Okay, so if it wants to be at 50 meters per second is always a velocity. This was my initial velocity, so this is my final velocity. Right? These are my givens. This is what I know. Now I got to figure out what I'm looking for. It says, how long would it take the plane? How long something takes, like if I say how long was that movie, or how long does it take to make that bag of popcorn, I'm looking for a time. Very good. All right, givens, unknown. Over to the equations. Hopefully you see this already. Acceleration, boom. Final, boom. Initial velocity, boom. Time, boom. We're using trusty number 1, all right? Acceleration equals final velocity minus initial velocity divided by time. Plug my numbers in. Acceleration is 2.5. Final velocity is 50, and minus initial velocity, make sure it doesn't look weird, is 0 divided by t. Okay, so this is a step up, all right? Now, the first thing I want to do is I want to simplify this, okay? And by that, 50 minus 0, that's 0, okay? So that can kind of go away, all right? So now, I have this. I'm just going to scoot this over. Okay, 2.5 equals 50 divided by time. We want time by itself. Can time be in the bottom of this fraction? Very good. No, it can't. So we got to move it. This is division. So we do the opposite of division, which, you guessed it, is multiplication. And we always multiply by the bottom number. So we're going to multiply this side by t. Whatever we do to this side, we got to do to this side. T divided by t here is 1. It cancels. I bring this down here. Now I have 2.5 times t equals 50. Right? This is multiplication. I still want to get the t by itself, so I have to do the opposite of multiplying, which is, very good, I got to divide. Okay, and I want the t by itself now, so I'm going to divide by 2.5. And whatever I do to this side, I have to do to this side. Okay, this gives me 2.5 divided by 2.5 is 1. That cancels out. And this, I got to put it over here, gives me t equals 20 seconds. Just put that in your calculator. 50 divided by 2.5 is 20. All right, one more. You got it. We got one more in us. Okay. All right, let's look at that same airplane. If the airplane is moving at 3 meters per second and accelerates at 2 meters per second squared for 4 seconds, how far will it travel? As always, step number 1, just write down what you know. An airplane is moving at 3 meters per second. We start the story. The airplane's initial velocity is 3 meters per second. We start there. It accelerates at 2 meters per second squared. Meters per second squared, always acceleration. For 4 seconds. Well, we know at this point, seconds is always time. Okay, that is all the numbers that we have. And our question here are unknown. What we're looking for is how far will it travel? How far something goes, right, is going to be distance. Excellent. So now let's go to our equations. All right, number 1. Well, we got acceleration, check. We got final velocity, no. And we don't even have distance, which is what we're looking for. So we can't use this one. Okay, what about this one? We got acceleration, check. We got final velocity, ooh, no. We got initial velocity and we got distance, but I can't use this, right? Because I don't know what my final velocity is. All right? But let's look at this last one. Distance is what I'm looking for. Initial velocity, check. Time, check. 1/2, that's a constant. Acceleration, check. Time, check. So we're going to use that last equation. I actually really like this equation, super useful. This is distance equals initial velocity times time plus 1/2 acceleration times time squared. It's a big one. This is a big boy. Don't worry. We can get through this. We plug in our numbers. D is equal to what I'm looking for. Initial velocity is 3. So we have 3 times our time, which is 4. Okay. And I like to put this in parentheses so as to not confuse myself. Plus, parentheses, 1/2 times my acceleration, which is 2, times my time, which is 4, squared. Okay? Now, just like I said before, the first thing you want to do here is PEMDAS. So we got to PEMDAS this. First thing, do the parentheses first. Okay? So I'm going to bring this down. 3 times 4 gives me 12. Okay. Plus, what's inside this parentheses? All right, we have to do our parentheses first, then exponents. So the next thing we got to do is figure out what 4 squared is. 4 squared is 4 times 4, which is 16. Okay. Now, all you got to do is in your calculator, you got to enter this. Mr. Norris, how do I enter in 1/2? If you don't know this, the easiest way to enter this in your calculator is to put in 0.5. They are the same thing. They equal each other. Okay, so instead of this, you're going to enter in 0.5 times 2 times 16, and you're actually going to get 16. All right, so I did this unit, then this one, and notice I did them separately. I even entered them into my calculator separately, or told you to. And the last thing we got to do is just add them up. 12 plus 16 gives me 28, and this is the distance, so I measure it in meters. All right? All right, guys, I understand this is a lot of work. I understand that this is a new era in our physics class, but I promise you, if you write down a chart, find the right equation, and just do the math slowly and carefully, you will get it, I promise, okay? Write down the notes, write down these practice problems just like I did, okay? Go back to them as you do your DOL. Find me when you have questions, all right? You guys be good.